Now there's more on the exam paper than I've got on the diagram, so let's read this through. The diagram's not drawn to scale. Well, that's always the case, isn't it? Or virtually always the case. There was that plot of land earlier that was drawn to scale. So we must appreciate that all diagrams are not drawn to scale unless we're told that they are. So this diagram's not drawn to scale. In the diagram, S, T and U are points on a circle. S, T and U are points on a circle with centre at O. Centre at O. The angle STU, where's that? STU, the angle STU is 63 degrees. So let's put that in there. It also says that XY is a tangent to the circle at the point T. So this is XY. Calculate the size. I'll put fine because it takes up less space. Calculate the size of the angle UTY. Calculate the size of the angle UTY. That's that one in there. And explain your answer. Give reasons for your answer. Right, it's a circle theorem question. When you have a circle theorem question, just look carefully at the diagram and see what facts, circle theorem facts, you can see. Well, there's a connection between a tangent and a diameter. There's the tangent, and there's the diameter. It passes through the centre because you're told that it does. And it's a fact, a circle theorem fact or angle fact, that the angle between a tangent and a diameter is always 90 degrees. So part 1 is to take 63 away from 90, leaving you with 27. Now if you explain your answer by writing down this, you get 0 for explaining your answer. That is not explaining your answer, that is not giving the reason. That's called showing you're working out, which is what I should have done there. Instead of just writing down 27, I should have written that, because that's called showing my working out. But very often I find that people answer these questions by writing down their working out and think that that's explaining the reason. It's not explaining the reason at all. It's showing you're working out. Explaining your reason, give your reasons, is to quote the circle theorem fact, the angle fact you're using. So I'm going to write down angle between tangent and diameter. You can use the word diameter or radius actually, because there's the radius and there's the diameter. Always 90 degrees. Now when you write down these reasons, they don't have to be long-winded essays, just enough information that tells the examiner you do fully understand the circle theorem you're using. So that's okay. Angle between a tangent and diameter is always 90 degrees if you like. Part 2 goes on to say, calculate or find the angle TSU. Where's that TSU? That's this one in here. Now in fact there are 2 ways you could do this, and often there is more than one way of doing a question. One way is to use the circle theorem. Angle in the semicircle is always 90 degrees. If you have a circle and you draw a diameter, the angle in the semicircle is always 90 degrees. So TUS is 90 degrees. So if that's 63 and that's 90, the angle I'm after the angle TSU, is 180, take away 63, take away 90. So that's my working out, isn't it? 180, take away 63, and take away 90. And that'll give you the answer 27 degrees. But like I said before, this is not the reason, this is the working out. The reason is the angle fact that I've used. So I shall write down because, could have written the word because there, couldn't I? Because angle in a semicircle always 90 degrees. You can also say, if you like, angle on a diameter. This is angle on a diameter is always 90 degrees. So there's more than one way of saying it. Angle in the semicircle is always 90 degrees, but I did also use an angle fact about the angles of a triangle adding up to 180. So, and angles in triangle add up to 180 degrees. And actually it's quite a lot of work there, because I think there's only one mark on that, but that's the way it goes. So on this first one I used one angle fact. Angle between a tangent and a diameter is always 90 degrees. But on the second part I used two angle facts. Angle in the semicircle is always 90 degrees. And I also used the angles in a triangle add up to 180. But there is another way of doing it. Now, I don't know how you feel about this, but if I can have another piece of paper, a bit short on paper, amazingly. Now let's use this piece of paper here. Let's look at another circle theorem. If you draw a circle and you draw a tangent, that's called the point of contact. If I now draw a line like that, that's called the chord. So that's a tangent, and that's a chord, and that's the angle between the tangent and the chord. And if I do that, that's called subtending a chord. And it happens that this angle is the same as that angle. And this is another circle theorem. Angle between a tangent and a chord equals the angle subtended by that chord in the alternate segment. Possibly the hardest of these circle theorems to write down. Angle between a tangent and a chord, that's the angle between a tangent and a chord, equals the angle subtended by that chord in the alternate segment. Sometimes it's called the alternate segment theorem. And in fact the examiner will let you get away with those three words, as long as you don't just say alternate angle, because that's a completely different thing. This is the alternate segment theorem. So in this particular question I could have just said that's 27 from part 1, so that equals that as 27, because there is the angle between the tangent and the chord, angle between the tangent and chord, and it equals the angle subtended by that chord. So I could have written a different reason down there. The examiner's not going to worry which way round you do that. So there's 1 mark for that answer and 1 mark for that reason. 1 mark for that answer and 1 mark for the pair of reasons, or the single reason I just gave then. Not a lot of marks for quite a bit of knowledge necessary there.